Today we're looking at 11.2 areas of circles and sectors. So what we want to do is find the area of a sector. Now if I'm looking at a circle, what a sector is if I took kind of like a pizza slice. So I have my center of my circle. If I want to just find the area of just one little piece of a circle, kind of like a pizza slice or a piece of pie slice, that would be the area of a sector. Now, an area of the whole circle, if you remember, is pi times our radius squared. Our radius is the distance between the center and the edge of the circle. This is our r. So we would take pi times that distance squared. Okay, so let's first find some areas. So our radius here on number 1 is 5. So I'm going to write that down. Radius equals 5. So to find the area of the circle, I'm going to take pi and then multiply it by my radius, which is 5 squared. Now this says to leave your answers in terms of pi. So what we're going to do is we're going to take 5 squared, which is 5 times 5, which is 25, and times it by pi. But normally when we write it, we put the number first and then the pi symbol. So this would be 25 pi. And our meters is our units, but when we do area, it would be meters squared. So it's how many square meters would be in this circle. So let's look at number 2. Now this time they do not give us the radius, they give us the diameter. So if the diameter is 9, that would be the distance across the whole circle. Half of that would be the radius. The radius would be 4.5. So to find the area, I'm going to have pi times my radius, which is 4.5 squared. If I take 4.5 squared, I get 20.25. So this would be pi times 20.25. And remember, we want to put the number first and then the pi symbol. So this would be 20.25 pi. Now, they have inches here. So when you're finding area, it's going to be your units squared. On number 3, I'm looking to see if the radius of a circle is doubled, what happens to its area. So let's look at number 1. My radius is 5. Let's double that radius. Let's give a radius of 10. And instead of 5 meters, we'll have 10 meters. And so I use my area formula, which is pi times my radius, which is 10 squared. This gives me a radius of 10 times 10 is 100 pi. So what happened, I went from 25 pi to 100 pi. So when I go from 25 to 100, this is 4 times as big. So if the radius is doubled, the area for any circle is going to be 4 times as big. And that is because whatever your radius is, when you times it by 2, that 2 is going to be squared. So 2 squared is 4. So it's going to be 4 times as big as what you started with. Okay, so again, a sector is just a pizza-shaped slice of a circle. Now, it's a fractional part of the circle. It can be found by multiplying the fraction by the area of the circle. So if I had a whole circle's area and I wanted half of it, I would take and times that area by 1/2 of the area of the circle. Now, we don't always have a perfect 1/2 here. Sometimes they'll give me something like 180 degrees. And this would be 180 degrees out of 360 degrees. Now, when you simplify this, this simplifies down to the 1/2. So what we can do instead is we take the angle that our sector is, and we divide it by how many degrees in a whole circle, which is 360. So we're going to take the area of a sector is the product. We're going to multiply the measure of the arc, so whatever this angle is, divided by 360, which is how much is in the whole circle, and then times that by the area of the circle. So this is a lot like the arc length that we talked about last time. So let's look at number 4. First, let's find the area of the whole circle. So to find the area of the whole circle, we're going to take area equals pi times my radius squared. Now my radius is the distance between the center and the edge of the circle, which is 3. 3 squared is 9. So I'm going to have 9 pi would be the area of the whole circle. See, we took a 3 here. 3 squared gives us the 9, and then we have the pi here. But we don't have the area of the whole circle. We just have a fraction of it. We have only 20 degrees out of the whole circle, which has 360 degrees. If I times straight across the top, I have 180 pi out of 360. The zeros cancel. 18 out of 36 is 1/2. So this would give us pi over 2 if we simplified it. We have meters on our circle as our unit, so area is meters squared. We have pi over 2 meters squared for this one. Looking at number 5, we want to find the area of the whole circle, which is pi times our radius squared. Our radius is 12, so if I put 12 in for my radius, 12 squared is 144. So the area of the whole circle is going to be 144 pi. But we don't have the area of the whole circle, we just have a fraction of the circle. We have 60 degrees out of 360 degrees. I'm going to simplify this by hand, but you can put this in your calculator. The zeros cancel out. 6 goes into 6 once, 6 goes into 36 6 times. So this is 144 pi all over 6. 6 goes into 144 24 times. So this would be 24 pi. Now our units are inches. So since it's area, it's going to be inches squared as our units. Number 6, we want to find the area of the sector. So first, let's find the area of the entire circle. Our radius is 2, so we're going to use the formula area equals pi times our radius squared. Since our radius is 2, we put the 2 in for the radius. 2 squared is 4. So the area of the whole circle would be 4 pi. And then we're going to multiply that by the degrees that we have. Now, we are given the 120, which is here. We need to get this number here. So there are 360 degrees in a circle. If we minus off this section here, that will give us what is left. So we're going to minus off the 120. That gives us 240 degrees out of 360 degrees. So this would be the area of the sector. You can put this in your calculator to simplify, but I'm just going to simplify it by hand. Four goes into 24 6 times. 4 goes into 36 9 times. 3 goes into 6 2 times. 3 goes into 9 3 times. 2 times 4 is 8 pi over 3. So this would be 8 pi over 3. Now we need to remember our units. Our units are centimeters. So our units here would be centimeters squared since we're looking at area. Now, number 7, we don't have a picture. If we don't have a picture, you may want to draw a picture. It's the area of a sector, so we're going to draw a circle here, and the sector is ABC. So I'm not really sure how many degrees not, since it's 135 degrees, that's a little less than half the circle. So we'll just kind of estimate. It doesn't have to be perfect. We're just going to put 135 degrees. I'm going to start with A. B is going to be the center of my circle because it's in the middle of ABC, and C is here. They tell us our diameter of our whole circle is 4 inches. So if the diameter is 4 inches, that would go across the whole circle. The radius would be half of that, which is 2. So there would be 2 here and 2 here, which adds up to 4. So we're going to start by finding the area of the whole circle, pi times our radius squared. If our radius is 2, we put a 2 in here. 2 squared is 4. So the area of the whole circle is going to be 4 pi. Now we're going to multiply that by the section that we're looking at. We're just looking for the section that's 135 degrees. We have 135 degrees divided by 360 degrees. Now we want to simplify this. You can put it in your calculator. I'm going to do it by hand though. I look at both of these and they're divisible by 5 because they end in 5 and 0. 5 goes into 135 27 times. 5 goes into 360 72 times. Now I'm looking at these and I know that 9 goes into both of them. 9 goes into 27 3 times. 9 goes into 72 8 times. I also am noticing that this 4, it's going to be in the numerator and the 8's in the denominator. 4 and 8 both have a 4 in common. So I'm going to cross cancel there. 4 will go into 4 once. 4 will go into 8 twice. And then 3 times 1 is 3 times pi. I have 3 pi all over 2. But you can also put that in your calculator if you would like. Now, I keep forgetting units. We need to remember the units. We have inches is what this diameter is in. So our area of that sector is going to be 3 pi over 2 inches squared. This time we're looking at the equation of a circle with a sector area of 35 degrees and the whole area of that sector is 15 pi feet squared. We want to find what the radius of the circle is. We're going to use this equation here where we find our area of our sector and we're going to solve for our r squared. So let's go ahead and just plug in our numbers. So in for our theta, we're going to put a 35 out of 360. We're going to multiply that by pi times our radius squared. And that's going to equal the area of the sector, which is 15 pi. And that's feet squared. But we can just know that when we do our radius, it would just be in feet. So we're going to just kind of ignore the units for now. We want to get r squared alone. So what we're going to do is we are going to start by doing a little trick to get rid of this fraction. We're going to time both sides by 360 over 35. And what happens is the 360s cancel and the 35s cancel. And then we're going to divide both sides by pi. And the pi's will cancel here. Now when I put that in my calculator, I just put 360 over 35 times by 15. The pi's were gone. And I get, as a fraction, I get 1080 over 7. And this, everything on the other side cancels except for the r squared. Now I want to get r alone. So what I'm going to do is I'm going to take the square root of both sides. Now when I think about square rooting both sides, I need to remember my plus or minus. But since a radius is always positive, I'm just going to keep it positive. So what I'm going to do is I'm going to take the square root and then I'm going to put my answer in and then it will just plug in exactly what it was. And I am going to get about, the radius is about 12.42